Down in your toolbox, you guys have got a vise that looks like this. Now this is what's called a rod vise. In order for us to work on our piston and rod assemblies, you guys are going to have to utilize this tool. So now that you have your piston and rod assembly out, we need to torque this cap up here so that we can measure the bore. But before you do that, and most of the time you're going to be doing this as you take the piston and rod assemblies out. So we want to separate the cap, and you want to just gently push your bearings out, and you want to put those in a safe place, lay them aside. So we need to take the bearings out, and now we need to put this on the correct way with both of the notches obviously facing the same side. So it goes like that. Now the thing about this is, the reason we need a rod vise is, number one, you don't ever want to put a connecting rod in a bench vise, it'll damage it. And the other thing is if I need to torque this, I need to go and I torque these bolts, I'm not going to be able to hold this and torque it. We need something to hold it, some type of holding fixture, and that's what the rod vise does. Now when you clamp up on this rod, you want to clamp on the big end bore, on this machined area here. This machined area is what controls your rod side clearance. They machine this from the factory. You don't ever want to clamp up on the beam of the rod up here, because if you try to torque it and you're clamped up here, you are going to bend the connecting rod. So the proper way to use a rod vise is to just clamp your connecting rod and piston in the vise on the big end. And then we take our torque wrench, and then you're going to torque your connecting rod bolts up to the spec that your instructor will give you. So there we've got it torqued up. Always take your torque wrench and take the tension off of it, always. If you leave the tension on this torque wrench and it sits for a length of time, it will damage the spring mechanism and cause damage to the wrench. Okay, now that we've got that done, you take your piston and rod assembly out, we've got our big end torqued up, and we have our bore here that we can measure. Okay guys, so now that we have got our connecting rod cap torqued on without the bearing, there's a few things we need to measure here. This is a T-gauge or a telescoping gauge. What we need to measure is we need to go ahead and put our T-gauge in the bore. Now this T-gauge has retractable fingers, so we want to put our T-gauge in that bore, rock it back and forth, kind of find the center here, and then we're going to lock that T-gauge in place, and we're going to carefully retract that. What we have done is we have duplicated the size of our bore here, and then you're going to take your micrometer. This is called a telescopic gauge, also can be called a transfer gauge. And then you're just going to take the appropriate micrometer, and we want to measure that T-gauge, and that is what we duplicated. So that's our bore size here, our rod bore. And then of course, once you get that measured, you're going to read the micrometer, and then you're just going to document the size of the bore and compare it to specs, because what we want to find out is that bore round? If it's out of round or tapered, then we're going to have a problem. So to check out a round, we're going to check it in multiple places. We're going to go in here, then we're going to go diagonally. To check for taper, we're going to measure one side of the bore, then we're going to go measure the other side. And that's going to tell us if that bore is tapered. And that is how we're going to diagnose the big end of the connecting rod. Now remember, it's very important that the rod cap is torqued before you take any of these measurements, otherwise you'll get a false reading. Now we turn our attention to the piston itself. There are a couple things you have to measure. One of them is ring side clearance. Now ring side clearance is the clearance between the thickness of that ring there and the ring groove. The ring has to be able to move on here. These rings actually rotate as the engine runs. So you can see the ring is moving freely in that groove. We have to check that ring groove clearance. So we want to take the appropriate feeler gauge, and we just want to stick that feeler gauge in there, and we want the biggest feeler gauge that will slide in. That's my smallest blade, and it's sliding pretty easy in there. So I'm probably going to go up a couple more until I get one that doesn't go. Like I said, the largest feeler blade that slides in between the ring and the ring groove, just like that, is your ring side clearance, okay? And we want to check both of them. We want to check them all, make sure, we need to make sure that all these rings move. So you're going to be checking these. That's one of your labs. Next, the lab is going to require you to remove the rings. Now, this is an old training aid piston that's never going to run. I'm going to show you what never to do. Never take this ring, pry it up, and roll it off of there. I just did years of damage to that ring if it were actually going to run, right? So you never want to roll the rings off and on. The manufacturer requires you to take the top and the second ring off with a tool and keep the ring level. You don't want to bend that ring or tweak it because it damages it. What we need to do is use a set of ring pliers. Now the way that these work is you've got these flat spots here and then you got these two little dimples here. So what I'm going to do is I'm going to push that ring out so that my gap is right there. You can see my gap. And I'm just going to slide this very carefully under that ring. And those two ends right there are going to catch the ring, and I'm just going to compress that or expand that far enough to get it off. And there you have removed your piston ring, okay? You got to do that to the top and the second ring. Our third ring is an oil ring on this engine. In our lab, you are not required to do anything with the oil ring. You just want to leave that on there. But I'm going to take my top and my second ring off because there's a couple of labs that you have to do with that ring. So I just get underneath it, same thing here, expand it just enough to get it off, and there is your ring removal tool. Another lab that's required here is groove width. Now the groove width, there's a lot of pressure on these ring grooves, and as they wear, these grooves can wear and get too big, and it causes the ring to start to flutter and it can break. So excessive groove width causes ring flutter and breakage. So we need to measure that. There is a spec for how wide that groove should be. Now, your feeler gauge set that you have, you guys, in your set does not have a feeler gauge big enough to measure these gaps. So what you're going to have to do, you want to look up your spec, you're going to have to double these feeler gauges up, right? So you want to find the right combination of feeler gauges that is going to fit in that groove snugly, and that's how you're going to check the groove width, is with stacked feeler gauges. Once you're done, you just add the number of feeler gauges that you have together, or you can also take those feeler gauges in there and you can use your micrometer and you can mic those feeler gauges and get the combination of gauges or get your size. Either way, it works. You can get your groove width that way. You got to check top and second. They are not the same. Another very important lab that you guys are going to do is we're going to check our ring end gap. Ring end gap is the gap at the end of the ring as measured when your ring is installed in the bore. Now, keep in mind, the ring has to be perfectly square here to get a good reading. So we want to put this up near the top. Now our piston that we took the rings off, we still have our oil ring on. So if we go down in the bore, the oil ring is going to catch the bore here, and that will square up that ring. So we use our piston, just go down until the oil ring catches the bore right there. You see it caught it? And now we have squared up our ring so we can check our gap and make sure it's within specs. Now at that point, you can see the gap. I'll put a light on it there. We just take our appropriate feeler gauges that are required and we measure the gap, and we want to make sure this is my specified gap here. This is, and you can see that field blade's going in there. I have enough clearance, okay? So that passes. This is the required amount of clearance that I have to have, and you can see it is going in. Mainly, you're just worried about these not being too small. Now, you are worried about them being too big too, but we don't want them super big. But if they're tight, it can blow the engine. If they're a little bit on the loose side, you're good. So we want to make sure that we check that gap and we document the amount of gap that we have, because that's really important for engine performance. That can actually cause serious damage if those are too tight.